Good morning, everybody, and welcome to today's NUSTEM COP26 encounter with Dr. Mike Rogerson from Northumbria University. Mike is an Earth Systems scientist. So, Mike, can you tell us a little bit about who you are and what exactly is an Earth Systems scientist? What do you do?
So I'm interested in how the whole world works as a whole system, particularly thinking about the climate and using the past of the climate to help us predict what the future changes are going to be. And the way I find out about the past of the Earth's climate is by looking for the chemical signatures, little chemical clues left in the mineral calcite. Calcite's what stalagmites are made of. It's what a lot of animal and plant skeletons are made of as well. It's incredibly common. It's a very frequently used material in all sorts of natural environments. So you can find it in all sorts of places from all sorts of times. And by measuring the chemistry of that calcite material, we can then work out what the climate was in the past. Very often things like rainfall are what we're chasing. And a good example is in the picture you can see going up now. This is the three of us sat in the desert next to a hole we've just dug. And this is the middle of the Sahara in Libya. It's taken us 2 days to get there. And believe it or not, we're actually chasing snail shells because this is the bottom of a river valley. And we've got out there and we've dug a hole in this area that used to be an old river valley. We found some snail shells in there. We then used the snail shells to confirm there really was a river, believe it or not, crossing through the dunes of the Sahara Desert. But also that the water was coming down from the Tibesti Mountains to the south. So the rain was happening down there. And the water was crossing all the way across the desert and making it all the way to the Mediterranean Sea. And we can read all of that just from some snail shells that we took out of the desert. And the three of us there, that's me and a PhD student whose student project this was, that's Anne, and Osama, who's our local guide who helped us get out there into the middle of the desert, which was quite a challenge, particularly to get the permits to do the work with permission. To get a more complete record rather than just a spot, a moment in time like that river, we often need something that's built in layers, that has a continual story recording it. And the picture you can see coming up now is me in a cave with a different colleague with a lovely pair of stalagmites and some stalactites coming down from the ceiling. And this is Moez Al-Mansoura. We're in Tunisia, and he's the director of geology at the Tunisian Geological Survey. We've been working for about 10 years now to look at the chemical signals recorded through these stalagmites, which is the rainfall history of Tunisia as it goes through time. And that rainfall history is really important to us because predicting rainfall changes in places like Tunisia are some of the hardest problems we're not really cracked yet in forecasting future climate change. And this is a really big project for us. So the next picture we're putting up is sort of the surface at the entrance to the cave. Believe it or not, that you're literally looking at the entrance. It's a bit of a squeeze to get in, but it's brilliant once you get inside there. That's us and a local farmer and a local fireman who are fantastic. And Khalifa in particular, who's standing up in that picture, is a farmer who works the hillside, who always comes underground with us. He's a wonderful host for the work, and we really couldn't do this stuff without him. And hopefully we can use these stalagmite records taken from the mountain under his farm to help us forecast better how rainfall will change in the future in that area.
Thank you, Mike. That's an excellent description of what you do there, and really interesting to see that you can you've got that that record in the rock, and you can look at those chemicals within the rock and be able to paint a picture of what it was like then and use that to predict the future.
The joy, and this is a little bit nerdy, is that stalagmites grew quite quickly, and so the crystals are quite imperfectly formed, and they trap little bits of water between the crystals. That's the actual rainwater from the actual past.
Oh wow! From how many? So amazing. From how many years ago?
The oldest one we've analysed from North Africa was 70,000 years old.
Wow, a raindrop of 70,000 years old. That's quite incredible.
It's a thrill, I tell you.
Brilliant. So let's move to our next question. What we are really interested in our COP26 encounters is what people working in the environment have found out about the climate. So what have you found out that you think is interesting or important for us to know?
So the most important work I do for the use of people, for the normal people, is the work in North Africa, because the IPCC do their best to predict what all climate futures will look like. Some of the most difficult things to predict are things like rainfall in the drylands. They have, in their terms, medium confidence that it'll get drier. And what we need to do is to better understand the physics that controls that rainfall. And to do that, we need to give them real things that have happened in the past that they can test their model and tweak the model until it gets the past right. And then it hopefully will get the future a little bit more confidently. And one of the things that we've been able to look at is that when it gets warm in Greenland, it gets wet across North Africa. And that's a little bit unexpected if you think about the forecast for a warming climate, we're getting wetter, but it might be to do with the specific way the Earth's orbit changes. We really do need to do some more work to understand properly why we sometimes get drying and sometimes get wetting as the Earth gets warmer. Because if we can't answer that question, we really can't help those governments make good decisions for the future.
Thank you, Mike. So we are asking all our climate experts to pose a question to the class today, something that they can have a discussion about that relates to maybe COP26, relates to climate change, but also relates to them in their local area. So do you have a question for the class?
So for my friends in North Africa, they're looking at this likely future of drier climate, and it's already pretty dry out there, and how they're going to cope with that. And the forecast for the north of England is that we'll get drier summers, but wetter winters. So what I'm interested to know is how you think that might feel like to live through. How will it feel like to have a dry summer and a wet winter each year as we go through the next 20 to 50 years?
So thank you very much to Mike today for coming along and talking to us. It's been really interesting learning about his work and the climate, and I hope you have a chance to answer that big question in class. Mike, thank you very much for coming along.
It's been a pleasure, Joe. It's always good to see people being interested in the climate future and beginning to knuckle down to think about what we're going to do about it.
Well, thank you, Mike, for spending some time with us this morning and talking to us about your research, who you are and what you do. And thank you for leaving us with that big question. We'll be back later in the week with another NUSTEM encounter with another one of our environmental scientists from Northumberland University, and we hope to see you there.